So welcome back. Next up is Thomas from Lacuna Space, and he's going to tell everything around doing IoT from space. Enjoy his talk.
Welcome here to our session at the Things Conference 2021. I very much appreciate the opportunity that the Things Conference is giving us today to show presentations, but also to interact. And I invite you to join our booth. Our whole team that was at the conference in real life last year will be here virtually and is eager to talk to you. So please reach out to us, come to our booth, look at our other workshops and demos, and talk to our team. As you can imagine, the COVID-19 situation also has affected Lacuna. We had delays in our satellite launches, in hardware deliveries. So we had hoped to be operational by now, and we have some delay in that. Today I will be sharing some good news as well, because we made a lot of progress and we are on track to provide a service to you, and we are almost ready to go. Let me get started with a very quick recap of what we do. If you want to know more, look at one of the presentations from the previous conferences. There's much more detail in there, and also in other online presentations. So in this diagram, let me start with you, the users. You have your application running on a LoRaWAN network server, an application server, and you have devices somewhere where they are in reach of a gateway. The messages from the devices reach your application via the LoRaWAN network server, and the gateways can be your own, they can be from a network operator. It really doesn't matter. It's transparent for your application. What we do is that we extend that system with satellite connectivity. So if you have devices like you see here on the left that are in very remote places where there is no gateway, or there is no possibility to put a gateway, or there is no economic reason to put a gateway, there we can pick up your messages via a satellite. The interesting thing here is that these devices are standard LoRaWAN devices. The only difference is they need a slightly different antenna, and they need some extra code to understand how to interact with the satellite. But other than that, these are standard LoRaWAN devices. So your devices know when the satellite is in view, they send their message, the satellite continues its orbit, it passes a ground station, it sends the messages down, the messages go to the network server and reach your application. From a user perspective, there's no difference from a device that sends a message to a terrestrial gateway versus a device that sends a message to a satellite gateway. There's one new thing in this picture here that you have not seen on previous versions, and that's the orange arrow that is pointing down. Our initial testing was with uplink only. With the newer generation satellites, we have bidirectional connectivity, so we can also send information to the devices, which is very important to also send updates on the system, to add satellites, and to make the whole system dynamic. The satellites we have operate in a low Earth orbit, which is between 500 and 600 kilometers altitude. They circle the Earth in around 9,500 minutes, which means they circle the Earth about 15 times per day. In the meantime, the Earth has rotated one rotation, and as you can see in this picture here, the satellite is in a polar orbit, and due to the Earth rotation, it basically scans the whole Earth in one day. So at any given location, you will see a certain satellite twice per day. Last year, I was at the stage of the Things Conference together with Johan and Wienke, and I was very excited to show the performance of our first satellite, LS1. And I had an example case where we had a sailing boat in the middle of the Atlantic Ocean, literally in the middle of the Atlantic Ocean, sending messages, standard LoRaWAN messages to our satellite. In the meantime, we have taken the lessons we learned from developing and operating LS1 and developed a new series of satellites called LS2 and 3 series. We did not only double the performance, such that we can pick up many more devices, but also in the more difficult local situations, but we also added a few features. Two of them are geolocation and the downlink capability. So with the geolocation, we can actually locate a device on the ground. So even if the device does not have a GPS and is not sending its position, we can tell you where the device is. One of the exciting parts of what we do is when the satellites are being launched. So the two launches we had since the previous conference were from Russia and from India. The interesting thing is here that those two launches went to different orbits. So the Soyuz launch from Russia is like the example I showed earlier, a polar orbit, where the satellite orbits around the North and the South Pole, and then the Earth rotates under it. The launch from India on the PSLV rocket is a more equatorial orbit. So that satellite reaches anything from the equator to about the north of Africa, so the Mediterranean, and south to South Africa. This satellite provides perfect extra coverage for countries like Australia, South America, Africa, obviously, and Southeast Asia. So it's a very good extra coverage for the areas where the service we offer is most relevant. So with this, we have now 4 payloads in space, and there will be 2 more early this year. So we have the satellites, we have the technology. Let's now look at a use case. As a proof of concept and a demo, I want to show you how to make a satellite-connected freezer. As you can see, my freezer does not have a very good view of the sky. And as with a GPS, if you want to have your Lacuna device talk to a satellite, it needs to be able to see the satellite. And inside the freezer, you cannot see the satellite. There are many use cases like that, where your sensor actually does not have a view of the sky. In this demo, I want to show you how we solve that problem. So on the left, you see a device, which will also be our development kit from RF things. It has an antenna and a complete LoRaWAN device, a standard LoRaWAN device with off-the-shelf chips in there. We will use this device outside as a relay. So it's not a gateway, it's a relay that can actually relay a few sensors to the satellite. For the sensor, I use the Things Industries generic node that has just been released. It's a very nice test because this hardware is new, the software is new. There are 2 more presentations from the people who developed this at the conference, and I would highly suggest you have a look at that. So for me, it was a perfect test. I only got this a few days before the recording here to test if this thing really works as easy as it is intended. As a generic node, it should be able to do anything. So monitoring the temperature in my freezer is very simple. It comes with all the software bundled, the firmware. So I changed the firmware to measure the temperature. I made a few modifications to send it to the relay on my roof. And I flashed it onto the generic node with an ST-Link programmer. That all took me less than half an hour from getting the node, unpacking the software, and getting my firmware running on that. The relay comes with standard software. The only thing you need to change there is the keys for the relay itself, because it reports its status, and the keys for the devices that it needs to relay. So those are my ingredients. Here you see how it works. The generic node is in my freezer. I close the door. I put my relay on the roof. The freezer starts sending temperatures at fixed intervals. The relay buffers them, analyzes them, and when the satellite is in view, it sends them to the satellite. The satellite forwards it to my LoRaWAN network server and my LoRaWAN application server, and in my application, I get the temperature. And I can see the temperature of my freezer is minus 17 degrees Celsius all over the satellite. So within an hour, with standard hardware, you have your application running over a satellite. Here's a project I like to share with you because it's very exciting. This is the Lunark project by the Saga Space architects, who built a habitat for living on the moon, and they tested it in Greenland with 2 people for 3 months in the middle of nowhere. Our friends Alex and Sheila from Space Tech Denmark provided the communication systems, and as part of that, they had a Lacuna device on top of the habitat to send status updates, but they also built, with support from LEGO and from the European Space Agency, a rover built from LEGO parts with Lacuna connectivity. So the people in the habitat put the rover outside. The rover starts exploring the area. It detects when the satellite is in view, sends its updates, and we receive the messages. This was also a perfect test for our geolocation service because we could tell exactly where the rover was at that moment while it did not send its own position. So the timing is perfect. There are so many developments now on the market, new modules and chips coming out. A few highlights here. Of course, from ST, the SoC, the system on a chip, the STM32WL. There are several modules already on the market. Seed is making things, RAC is making them. On the bottom you see the 1SJ module, also with an MCU and a radio chip from Murata. Also a very good chip to use directly with the satellite. And in the middle you see a module from Miramiko, a manufacturer of LoRaWAN modules and devices, with the LR1110, which again is a very good match with the satellite service. For example, if you connect it to the antenna you see on the right, this is an antenna that has all the functionality in there to talk to the Lacuna satellite, to receive the GPS, and to have a Wi-Fi connectivity. Here's one more example where you see one of our own development boards with the LR1110, a Lacuna antenna, GPS antenna here as two separate antennas. But I also want to point your attention to the battery there, because this is really low power. It's the same power as that you use on your devices to send to a terrestrial gateway. This is truly low power. That very small battery there can send messages to a satellite. That is unique. There's not any other system that can actually do that at these power levels. So I want to highlight again the difference, or the unique thing that Lacuna does is that it enables the existing ecosystem to talk to a satellite. So we are not selling you very expensive modems with closed firmware, so basically a black box that you need to integrate in your hardware. No, we enable your existing hardware to talk to a satellite. It is also economically much more feasible because now you can develop a device, and the generic node is an example of that, where you develop both for the terrestrial and for the satellite network. So your investment in the development is used for many more use cases than just the satellite. And for example, the generic node has a built-in antenna from Fractus, but it also has a connector to connect to an external antenna. So all you need is an antenna, the software to understand how to operate with the satellite, and one of the many chips or modules that are available. And with that, we create a truly open system to talk to a satellite. All the software will be there. You can use whatever we provide. If you think you can do it better, you can adapt it. If you like the open source strategy, you can contribute back to the community, or you do your own thing. It's all fine. It's up to you. You have full control over what you're going to do. There are no black boxes, no hidden costs. It's all in your hands. So, what's next? Where are we going? We have 4 payloads in space right now. There will be 2 more satellite launches in early this year, and with that we plan to have commercial service in September 2021. So we're almost there. Stay tuned. Again, I'm very happy with all the requests we get. It doesn't go unnoticed. We will reach out to you when the time is there. In the meantime, we have 2 programs, a technology partnership program for device manufacturers who want to be ready to sell devices in large quantities by the time we get operational. So please reach out to us if you want to talk about that. And there will be a very limited evaluation service earlier than September, again for very big use cases to get experience. Again, reach out to us. So the whole team is here. Please talk to us here at the conference. Let's make use of all the interactive options we have here and discuss all the things we can do together. Before I end this presentation, there's one more thing. Within a few months, we will be sharing more information about the next big step, because we're not going to stop with these few satellites. That's an initial service. We have very nice plans for a big constellation, and we will be announcing some interesting news about that in the next few months. Thank you again. It was a pleasure to talk to you, this time in a one-way direction, but hopefully I will meet many of you here at the Things Conference virtually online. Happy to talk to you. Thanks again and stay tuned. Bye.